let's go to page 351 and let's do number 568. It says let K be in square unit the area of a trapezoid. Okay, so you have a trapezoid with the area K such that the shorter base, the altitude, and the longer base in that order are arithmetic progression. Okay, so I'm going to, since a progression, I'm going to call this x, and this, the height, altitude would be x plus d, and the longer base would be x plus 2d. Okay, so which of the following must be kb? An integer, a rational number, or irrational number? Okay, so the area of a trapezoid is equal to the bottom base plus the top base plus the bottom base over 2, so that gives you the average, and you times by the height, which is x plus d. Okay, so you can b1 plus b2 over 2 times the height, that will give you the area for the trapezoid. And so let's go and work it out. So this will equal to 2x plus 2d over 2 times x plus d. And the 2 cancel out, so k equal to x plus d squared. And this is all we have. So since there's no additional information that we cannot conclude that it must be any one of those. Okay, so does it have to be an integer? No, because we don't have enough information. Okay, and does it have to be a rational number? No, again we don't have enough information to determine. So answer will be none. Okay, it does not have to be any one of those listed. Okay, let's go to 569. Okay, how many digits are in the product of? Okay, so you have this long number. Now, best thing to do is just go ahead and just go and write in a scientific notation. So first number is 3.66 times 10 to the 18th power, and the second one, you want to times it by 3.43 times 10 to the 14. And you can do it manually. You can just go and do 3.7 times 3.4. So you're going to end up with 12.6 times 10 to the 32. And this is equal to 1.3 times 10 to the 33. And there will be 34 digits. Okay. Because the number of digits would be, so 33 means you move this over 33 places. So you will have one digit over here, and you move over 33 more, so you give you a total of 34 digits. Okay. And that's it. Okay, let's go to page 351 and do number 570. So if this common multiple of, so you have the, so LCM of 10 factorial, 18 factorial, and 12 factorial, 7 factorial is expressed as a form of, so this is equal to A factorial, B factorial over C factorial, where A, B are 2 digits and C is a 1 digit. Okay, so these are 2 digits, and this is 1 digit. You're looking for A, B, C equal to 1. Okay. So what we need to do first is apply the definition. So the 10 factorial So let's go and write this out. So you have the, so to do the LCM, you do the factoring thing. So you got 10 factorial. Then the 18 factorial would be 18 times 17 factorial, right? And this one over here, I'm going to do the same thing. So I'm trying to get a common things. Okay, so this is 17 factorial. That's why I'm writing it out this way. Now the 12 factorial with 10 factorial, I'm going to write out 12, 11, and then after is 10 factorial. So that is this one here, and this one I got 17 factorial. So again, so I expand this by a little bit, so I get a 17 factorial to match these. This one I expand a little bit, so I can have the 10 factorial to match that. So I'm gonna, so now I can factor out the 10 factorial and 17 factorial. Okay, so I end up with 18, and this one I end up with 12 and 11. Okay, and then next I'm gonna factor out the 6. So I get 3 and 2 times 11. Okay, so LCM would be equal to this whole thing. So LCM will equal to 10 factorial, 17 factorial, and the 6, and the 3, and the 2, and the 11. Okay. Okay. So now we try to get into this format. Okay. So what I'm going to do is this and this would become 11 factorial. So this one and this one would become 11 factorial. And also with this one here. So this, so I got 11 and okay. Okay. So use this one here. So this and this will give me 11 factorial. And I also have a 12 over here. I'm going to highlight this. So this will give me 18 factorial. So I have 11 factorial, 18 factorial, and a 2. So now I need to get into this down here. So to get these, I need to get rid of this number. To get rid of this number, I need to get to the next number so I can combine. So what I need to do is I'm going to multiply by 6. So I'm going to multiply by 6 and divide by 6. Okay. And the reason I need to get the 6 is so I can get rid of this 2. Okay. 2 times 6 will give me 12, so I can combine with this one to get 12 factorial. Okay. Okay, so now I have 12 over here. So 12 and 11 factorial, this will give me a 12 factorial. Okay, I'm going to write the 18 factorial first. So the blue one, again, 2 times 6 is 12. 12 and 11 factorial would be 12 factorial. Okay, and the 6 is equal to 3 times 2 times 1. So this is equal to 3 factorial. So this one equal to 3 factorial. So now we match the criteria over here. So from here you can see that the A equal to 18, B equal to 12, and C equal to 3. Okay. So A, B, C will equal to 18 times 12 times 3, and this will equal to 648. Okay, let's go to the next one. Okay, find x in terms of a, b, and c if x over a equal to y over b equal to z over c equal to xyz over x plus y plus z. Okay, so first let's go and make into pairs. So I'm going to make this pair with that. Okay, so x over a equal to x y z over x plus y plus z. And then I'm going to separate this. I'm going to kind of just using this pair over here. So you got x over a equal to y over b, and I'm going to use this one over here. So I got x over a equal to z over c. So I'm going to solve for y, and I'm going to, since we're looking for x, right? So I'm going to solve for the y and the z to substitute into here. Okay. So over here, move this over, so y equal to xb over a. Over here, move this over, so you got z equal to xc over a. Then I'm going to substitute this into this equation. Okay. Now over here, since I got x on both sides, I can get rid of the x. So I got 1 over a equal to yz over x plus y plus z. And then I'm going to cross multiply. So I got x plus y plus z equal to a y z. Now I'm going to substitute this into here. So x plus, so y is xb over a, z is xc over a equal to a times y is xb over a, z is xc over a. Okay, now this one can cancel out. That's 1a to cancel out. And I'm going to make this into common denominator. So I got ax plus bx plus cx equal to bcx squared over a. And now both sides have a, so the a can cancel out. And I also can get rid of dividing by the x. So notice got x, 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 and x squared, right? So I'm going to get rid of the x. So I got a plus b plus c equal to bcx. Then after that, I'm going to divide, move these things down. So I got x equal to a plus b plus c over bc. And that's it. So just a lot of algebra, moving things around. Okay, next one. Okay, number 571. 72. Just this 71. Okay, 572. It shows that if the two roots, so you got ax squared plus 2bx plus c equal to 0. So two roots are the same, that means it's double root. So if you have double root, that means the discriminant d equal to 0. Okay, and so what we're looking for, and it says ABC form a geometric. Okay. So A, B, C are geometric. Okay, so first, let's go and find the discriminant. So discriminant is equal to b squared minus 4ac. So this came from the quadratic formula that x equal to negative b plus or minus square root of b squared minus 4ac over 2a. So the discriminant is this over here. Okay, so that is your discriminant. So this is your d. Okay, so d equal to b squared minus 4ac. So since it's double root, this is equal to 0. Okay, so 0 equal to b squared b. Now, don't get confused between this b and this b. Okay, so this b is actually the 2b. Okay, so it'd be 2b squared minus 4 A, C. Okay, so the A and the C are the same, but the B, so this B is equal to this 2B over here. So just be careful with that. Okay, and I'm going to move this over. So 4B squared equal to 4AC. Get rid of the 4, so B squared equal to AC. And so take the square root, so B equal to the square root of AC. So therefore, you see that this is a geometric mean. This is the definition of geometric mean. So since B is the geometric mean of AC, therefore this must be geometric. Okay. So again, B is so B is geometric mean of A and C. So therefore, A, B, C are geometric. Okay, let's go to the next one. Okay, so you have 10 to the 1 over 11th power, 10 to the 2 over 11th power, 10 to the 3 over 11th power, all the way to 10 to the n over 11th power. Okay, what is the smallest value of n such that the product of the n number of terms of this sequence? Okay, so when you multiply all this together, means you have to add the exponents. Okay, so that means the 1 over 11 plus 2 over 11 plus da 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 all the way to n over 11, and this has to be less than what the 100,000 is equal to 10 to the 5. Okay, so when you add all this together, this has to be, so when you add all this together, this has to be less than that. That means exponent, when you add all the exponents, have to be less than 5. Okay. Okay. So again, if you don't see it, so again, the product, when you multiply all these, you have to add the exponents. Okay. So again, if we back up a little bit, so you got these, right? So you times all this together, and this has to be less than 10 to the 5. Okay. This has to be less than that, less than 100,000. So that means again, when you multiply the exponents, so this would be less than 10 to the 5, right? So that if you just compare the exponents, that means that when you add all the exponents, you have to add less than 5. Okay. So I'm going to multiply everything by 11. So you got 1 plus 2 plus 3 plus da 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 plus n have to be less than 55. So you can multiply everything by 11. Okay. And so from here, I can apply the sum formula. So you got 1 plus n, right? So that's each pair times n over 2, give you number of pairs, have to be less than 55. Okay, so multiply by 2. And so these are two consecutive, instead of trying to use quadratic, so you can see that these are two consecutive numbers. So, and you notice that this is, I'm going to do this, okay? Okay, so you can just by matching, you can see n equal to 10, n equal to okay, let's see, such that okay, oh, this has to be greater than, have this backward. Okay, so looking for the greatest, smallest value. So you want to have this greater than, I have this backward. Okay, so you want to have it greater than. So you're looking for the smallest n, this would be greater than that. Okay, there we go. Okay, so if n equal to 10, it would be equal. So n had to be equal to 11 to be greater than. Okay, so you can, if n equal to 10, it would be equal. Okay, so you can see that when n equal to 10, both sides are equal. But you want to exceed, you want to be more than that. You want this to be more than that. So n had to be 11. Okay. Okay, let's go to the next one. Okay, it's a line with a slope of 6. Bisect the area of units squared with a vertex. Okay, so you have a square with a vertex of 0, 1, 1, 1, 1, 0, and 0, 0. Okay, so since it's going to bisect, if it's going to bisect the area of the square, you have to go to the center, and the slope is equal to 6. So this coordinate to the center is coordinate of 1/2, 1/2, and the slope is equal to 6. So this is a very straightforward point slope type of problem. So again, in order to bisect the area, you have to go through the center of the square, and therefore you have to go through this point 1/2, 1/2. Okay, so let's apply the point slope formula. So y minus 1/2 equal to 6 times y minus x minus 1/2. Okay, and go ahead and work it out. So y minus 1/2 equal to 6x minus 3. Now go ahead and plus 1/2 plus 1/2. So y equal to 6x minus 5/2. So your intercept is, so b equal to negative 5/2. So the point that it would go through here would be 0, comma, negative 5/2.